All right, so let's moving on to section 2.4. The focus on this is really using our making ability to make sense of fractions to compare them. So in other words, comparing fractions by reasoning. Now, all of the standard ways to compare fractions are going to be not permitted here. So we're going to try to do comparing without using the common denominator or cross multiplying or converting to decimals or to percent. So notice here in other ways than this. So what's left? Well, what's left is actually trying to make sense of what each one of these fractions means. So let's write this out. Now, 2O is not something, it's not a core activity, but I'd like to go through it with you so that we have a common understanding of how we can compare fractions. So if we look at 1/49th and 1/39th, well, we know that we have the bottom number, right, the denominator, tells us how large the pieces are. So with 1/49th, we know that we need 49 of them to fill the whole. And the top number tells us how many of them how many of them we have. So comparing 49 and 39, well, the 49, if we need more of them, they're going to be smaller. And these are going to be larger pieces. And one of them, we have the same number. Same number. So if we have one smaller piece versus one larger piece, what do we have, in which case do we have more? Well, the 1/39th is going to be more because it's one larger piece than one smaller piece. If we look at part B, which one is smaller and which one is larger? 37th smaller or 45th smaller? Well, the 45th, we need more of them to fill the whole. So this will be smaller, this will be larger. And we have 7 of each of them. So same number. Same number. So would you like to have 7 of the larger pieces or 7 of the smaller pieces? Well, 7 of the larger pieces are going to be greater. So notice that we have gone to make sense of our fractions based on reasoning rather than based on any kind of cross multiplying or common denominators or anything like that. And in fact, finding common denominators between 49 and 39 is not going to be my idea of fun. So let's see if we can use the same kind of strategies for these problems. So I've numbered them A through G. So let's see what we can do with these. So A, which one is smaller and which one is bigger? Which pieces are smaller and which pieces are bigger? Well, if we're looking at 43rds and 45ths, the 43rds, you need fewer of them to fill the whole. So these are going to be larger pieces. These are going to be smaller pieces. And we have 27 of the larger pieces and 26 of the smaller pieces. So we have more larger and fewer smaller. So would you like to have more larger pieces or fewer smaller pieces? So in this case, we know that we would really want more larger pieces. And B, 13/25 and 34/70. See what we can do with this one. Now, 13/25, 25ths are larger. And then 70ths. 13 of them versus 34 of them. Well, this is fewer. And this is more. So would you like fewer larger pieces or more smaller pieces? Well, this one is not so clear cut. We don't know whether larger pieces, how much larger the pieces are or how many fewer we have. So we don't really know. We need to have some other kind of reasoning. So sometimes it helps to put these numbers somewhere on an open number line. Open means that I don't have to draw the 1 and the 0 and all of that. I just need to figure out kind of where they are. relative to each other. So where do you think these numbers are? 34/70ths and 13/25ths. If you think about it, if you need 70 of the pieces to fill the hole, then and you have 34 of them, you're close to a half, right? Now, do you have more than a half or less than a half? Makes sense that you need 35/70ths to fill the half of it. So 34/70ths would be kind of here somewhere. And for 13/25ths, well, is that more than a half or less than a half? Well, 12.5/25ths would be more than a half. So 13/25ths would be somewhere there. So which one is greater, 13/25ths or 34/70ths? Well, the one that's greater than a half is going to be greater. So notice that we compared, instead of to each other, we actually compared both numbers to 1/2, to a common benchmark, to see if we could make sense of their relative sizes. 17/18ths, 19/20ths. And then for D, we have 9/40ths and 12/44ths. So let's see if we can make sense of these. 17/18ths, so 18ths are larger, and there are fewer of them. And 20ths are smaller, but we have more of them. Again, we're in that situation that we're not quite sure. It depends on how much larger and how many fewer we have, but this isn't enough information for us to compare. So let's see if we can make sense of the numbers. What are they close to? It looks like they're really close to 1. They're just short of 1. 1 piece short of 1, right? So 17/18ths, you need 1 more 18th. And then 19/20ths, you need 1 more 20th. So if this is our 17/18ths, this is our 1/18th that we're missing. Where would 19/20ths be? Is that 20th smaller or larger than the 18th? Well, we have it here. The 20ths are actually smaller. So the piece that it's missing is going to be somewhere inside. Whatever the distance, whatever the size, the relative size is, but it's going to be somewhere here. So which one is greater? Well, 19/20ths is greater. It's missing a smaller piece to get to 1. So notice, just like the 1/2, with the 1/2, with part B, we couldn't compare the two numbers to each other, but we could compare to a different number. So let's do the similar kind of thing with D. So these are larger because we need fewer of them to fill the hole, and we have fewer of them. And these are smaller, and we have more of them. So again, we can't be comparing them to each other directly. So let's pick a number that's really close. So 9/40ths and 12/44ths. Looks like a quarter. All right, about a quarter. Now 9/40ths is where? 9/40ths, well, 10/40ths is a quarter. So 9/40ths is going to be somewhere here. And 12/44ths, well, 11/44ths is a quarter. So 12/44ths is more than a quarter. So we can compare, and we can say that 12/44ths is greater than 9/40ths. And the final two, we have 3. 51/53rd, 65/67ths, and 13/25ths, 5/8. So let's see this E, 51/53rds and 65/67ths. Well, these were larger pieces, and there are fewer of them. And these are smaller pieces, and there are more of them. So again, we can't compare because we don't know how much larger and how much fewer we have. But we can look at the number line. And it looks like, again, we're really close to 1, but here we're missing 2 pieces from both of the fractions, right? For both of the fractions, we're missing 2 pieces from the full 1. So if this is 51/53rd, this would be 52/53rds, right? This is our 1/53rd that we're missing. In fact, we're missing 2 of them. And if we look at 66, 67ths, we're missing 2 67ths. Now, are 67ths going to be greater than or smaller than 53rds? When we looked at them, they're smaller. So this would be our 1/67th, and maybe another 67th. I'm not sure where that's going to land, but I do know that at the end, we're going to be missing less than in 53rds. So this is going to be a greater fraction because we're missing less to get to 1. We're less short to get to 1 than we are with the 53rds. We're missing smaller pieces. Now let's look at this one. So these are smaller, but we have more of them. And these are larger, but we have fewer of them. Again, in a situation where we need to try to make sense of where we are. And it looks like both of those numbers are hanging around 2. Oh, sorry, pardon me, 1/2. So 13/25. Now, 13/25 is somewhere to the right. It's 12.5/25 is half. And 5/8, well, 4/8 is a half, so this is also somewhere on here. Not enough information with that strategy either. So let's see what we can do to figure out which one is larger. Well, 13/25 is 1/2, and how much more? Well, 12.5/25 is half, so this would be 0.5/25. Right, so we got to go 0.5/25. And for this one, for 5/8, it's 1/2, which is 4/8, plus 1/8. So now we want to compare 1/2 of a 25th or 1/8. So this is larger and this is smaller. So 1/8, this is 1/8. And 1/2 of a 25th is going to be in here. Which one is going to be greater? And you can see that 1/8 is going to be greater. So it will, the 5/8 is greater than 13/25. Again, without any common denominators or any other kinds of procedures that we'd used before. All right, and finally, G, 37/35 and 27/25. Well, if we look at this number, we have smaller pieces, but we have more of them, and we have larger pieces, and we have fewer of them. That's not going to help us much on its own, but we can look at some numbers that are close by, and it looks to me that they're close to 1. They're each 2 pieces over 1. So which pieces are smaller? Well, the 35ths are smaller, and the 27/25 are actually larger. So wherever they land, the 27/25 are going to be greater than 37/35. I hope this makes sense as you look at these different strategies of comparing fractions, that you see that you don't need to have any of those procedures, any of the common denominator, cross multiplying, or converting to decimals to compare by far most of the fractions. You should be able to make sense, or at least have an estimate of what those fractions are worth and which one is greater.